All right, so we have a multiple choice question on the Chapter 3 review packet that's about the intermediate value theorem. I know you can't see my entire paper here, but we'll make it work. The intermediate value theorem basically just says that as you change in x values, you have to go through all the y values if you've got a continuous line connecting two different dots, basically. So we're going to look at that in a little bit of detail here. I know you had a multiple choice question on your review, but this question, instead of being multiple choice, will just kind of be free response. What can we figure out? So if f of -4 is 2 and f of 3 is -3, what can we conclude about the function f based on the intermediate value theorem? So the first thing we do whenever we see anything about the intermediate value theorem or any of these guys is to just do a quick sketch of the information they've given us. So they've said that f of -4 equals 2. There we go. And f of 3 equals -3. It doesn't even matter if we label these. As long as we can see that we start here, we stop here. So I have no idea what my function's doing in between these two dots. All I know is that these two dots exist and my function is continuous because they're asking me to use that intermediate value theorem. So my function's going to be a nonstop continuous line connecting these two things. It could be something as simple as a straight line with a constant slope. It could be something as complex as a curve with multiple maximums and minimums. I really don't know what's going on here, right? So because I don't know, I can only suppose about what's going on in the middle. The important thing is that I know my x and y values, where those start. I know my intervals where this function exists. So f of -4 means that was a -4 in my x value, right? And I ended down here at f of 3, so that's a 3 on my on my x value. And my y values here exist from 2 here to -3 here, right? 2, -3. I drew that a little low, but that's that line there. All right. So what I'm going to do is I'm just going to kind of encapsulate the intervals that are going on here with some dotted lines. So -4 is on my x-axis and 3 is on my x-axis. So my function exists that I know of from -4 to 3. That's going on there. And my y values exist from -2 to -3. From 2 to -3. So we always read from bottom to top, from -3 to 2. So basically what the intermediate value theorem says is just that as we move from -4 to 3, we have to cross all of the y values between these two coordinates as we go. We can't like skip a y value and jump over it. If it's a continuous line, it has to go through all of these y values as it moves along this path. Whatever the path is, we're going to cross every number between -3 and 2 as we move between -4 and 3. That's all the intermediate value theorem says. So we can make some suppositions. We can go ahead and suppose that there must be one value of x somewhere in here such that, so this is one value, at least one value. That's going to be important. There must be at least one value of x such that f of that value equals -2. Somewhere in here, I have to cross through -2. That's going to be the dotted line that'll go right here, right above -3. So somewhere in here, I cross that once. There's one f of x that gives me a -2 as I go from -4 to 3, right? I have to cross that line. I get -2 as a y value somewhere in there, okay? That's not the only conclusion that I can draw. I can also say there must be at least one value of x such that my y values f of x equals -1. That's also a place where this function must exist, -1, right on this line, right? The main thing is that this x value, such that f of x is -2 or such that f of x is -1, this is going to have to happen in my x interval. So between -4 and 3. So at least one value of x between -4 and 3, such that my f of x, my y value, is -2. It has to happen at least once. Or such that f of x equals -1. That has to happen at least once. We can kind of see, if we look at the first little straight line that I drew, if our function does go straight down like this at a constant slope, I can see that if I'm talking about where it's crossing y equals -1, it happens right here. This is my x value. So there's at least one x where that's true, right? This f of this x gives me a -1. So I know that happens at least one time. If we're looking at this big crazy curve and looking to find where it equals -1, I can see that this curve is equal to -1 here, and here, and here, and that's it. So I have 3 different places where this is true. But again, there's at least one value where that's true.